those out there every once in a while. In a group, they are related by properties. The halogen column, all reactive nonmetals. We saw that video about bromine and the fiery pit of hell. The noble gases, all non-reactive gases. The alkali metals, we did a demonstration in class where we put lithium, sodium, and potassium in water to see how that reacted. We also saw a recap of that, several different electronic sources. You can go back and look at it on the links I have on Moodle. Properties are what group things together in a family. They have characteristics that are similar. How they react, their appearance, densities, melting points, boiling points, all that kind of stuff. Test hint number 11. The specific names of the main group elements. Specific names. Now, not every group has a fancy schmancy name, but there are some very common ones. Column 1, the alkali metals. Again, lithium, sodium, potassium, we saw their reactions. Column 2 are the alkaline earth. So their name is similar to the alkali metals. Their properties are also similar, but they're not quite as reactive as the alkali metals. Our D block we call transition metals, kind of as a whole group. The P block element, we're over here on the non-metal side of the table. The elements in column 13 that start with boron are just called the boron family. They don't really have a fancy name. And next to that, carbons column is just called the carbon family. The nitrogen column, I've always heard it called just the nitrogen family, but that does have a name called the pnictogens. And like I said in class, I'm not sure if I'm really pronouncing that right, but it's fun to say. Oxygen family are the chalcogens. Fluorine's family is the halogens. And hydrogen's family, the noble gases. Okay, so this question will ask you about one of them probably. Test hint number 12. The specific names of the main group elements again. I'm not going crazy. I'm really reading the same test hint twice in a row. So now we're going to ask you the same kind of question in a different way. Maybe I'll ask you about a couple specific elements and you'll have to tell me what family they're in, as opposed to a question that's saying, well, you know, column 2 is called the what? Test hint number 13 says the sublevels that fill in each period on the periodic table. If you can read from left to right, top to bottom, and you remember all those electron configurations that we spent so much time on in chapter 4, you should have no problem. If we go across row 1, period 1, we only have an S block. Period 2, SP. Just read it left to right. Period 3 has S and P. Period 4 has S, D, and P. Period 5, the same. And it's not until we get down here to period 6 where we would have S, F, D, P. And take a look at the question carefully. Is it asking about the period, which just means the row, or is it asking about the energy level, where you'd have to be worried about that little zigzag down for the D block with the orbital overlap. Test hint number 14 says how sublevels relate to periods and how that relates to the number of elements in a given period. Well, we kind of covered that in the last one. An s orbital can hold 2 electrons, so there's going to be 2 elements in a row that just has an s orbital. There are 3 p orbitals, each holding 2 electrons, so we're going to have 6 elements across plus the 2 s's. That's why we get 8 in the second period. There are 5 d orbitals, each holding 2 electrons, so we have 10 elements across the d block, and within that period we'd have the 2 boxes for the s, 10 for the d, and 6 for the p. Okay, so you're looking at how many sublevels and what kind they are, and the fact that they each hold 2 electrons to figure out the size of the row, which you can tell at a glance because we've already spent a lot of time building our understanding of the periodic table by doing configurations. Number 15, test hint says what the classification of an element is based on its electron configuration. Probably a little confused about that. I maybe didn't word that all that great. So it's asking you what kind of element is. To give an example. So if I say something that ends S2, well, you know, S2 is over here on the metal side. That's going to be a metal, actually an alkaline earth metal. If it says S2P3, well then you know you're over here in nitrogen's column. So that would be a non-metal if it's up towards the top on the periodic table, or a metalloid if it's in the middle, maybe a heavy metal if it's on the bottom. If it says S2D5, then you know you're somewhere in the D block and it's a transition metal. Okay, so what kind of element based on where you're ending up in the periodic table when you're given the configuration. Test hint number 16. You need to know where the metals, nonmetals, and metalloids are. Okay. You know that the zigzag is the dividing line, and I don't have a very good one here on this table, but everything to the left and down from that zigzag line, those are metals. Most of the elements on the periodic table, most of the elements we have are metals. Hydrogen is our exception over on this side. Hydrogen can also be placed in column 17. Right next to helium, we know it is a non-metal. In this upper right corner, we have nonmetals, and then the elements that sit on that borderline, that zigzag, are the metalloids. Boron, silicon, germanium, arsenic, antimony, tellurium, and then some classify astatine as a metalloid as well. Okay? So just a handful of metalloids, a few nonmetals in this upper right corner, and then the majority of things on the chart are metals. Moving right along to test hint 18. Why hydrogen and helium are exceptions on the periodic table. It goes back to their electron configuration and the fact that that first energy level closest to the nucleus can only hold 2 electrons. It's very small. There's not much room close to the nucleus, as you well know from your last chapter. Because that energy level can only hold 2 electrons, we have its outer shell filled with just 2 for helium. So it's a noble gas, but it doesn't have the octet like everybody else does in that column. And on the hydrogen side, we have an element that could lose a valence electron, the only one it has, like the column 1 metals, but it can also gain 1 valence electron, like the halogens, to get that full outer shell. So hydrogen does do double duty, trying to act like a metal, and also able to act like a nonmetal, and certainly can share with covalent bonding, which we'll be getting to pretty soon. So that small energy level is what sets them apart. Test hint number 9.